All right, let's see how you did on this practice one. So a car starts at 10 meters per second at the origin and has an acceleration of 3.5 minus 0.5 t meters per second squared. So they give you the acceleration. So now they also give you the initial velocity and the initial position. The reason they're giving those to you is those are essentially your constants of integration. And so when we integrate that acceleration function to get our velocity function, we're going to have essentially that plus c, which is our initial velocity, our velocity at time 0. And so we need to put that in there. When we integrate our velocity function to get our position function, our constant is 0, our x naught is 0. Now, when they ask the next couple questions, so one of them says v max. Well, v max occurs when the acceleration equals 0. So what we need to do is we need to find at what time does acceleration equal 0, then plug that time into our velocity function to find our maximum velocity. So set our acceleration function equal to 0, solve for time, plug that time into your velocity function, solve for velocity. That is your maximum velocity. Part B wants you to find the position and time when that occurs. Well, we already found the time. So all we need to do to find the position is just to plug 7 seconds into our position function to find that position. Part C says, at what time and position does the object switch directions of motion? So switch directions of motion means you're flipping from either a positive velocity to a negative velocity or a negative velocity to a positive velocity. Whenever you're switching from a positive to a negative number, you always have to go through 0. So it's kind of similar to this. And another way to think about switching directions of motion is if I'm going this way and I switch directions of motion, that was my maximum position. So similar to here, to find a maximum velocity, you look at the derivative and set it equal to 0. So to find a maximum position, I would look at the derivative and set it equal to 0. So same kind of pattern there. It's just instead of calling it a maximum position, they talk about it as a switch of directions. So go ahead, set your velocity function equal to 0. Looks like you're going to have to plug that into Solver or Polysimul 2, either one. Solve for that time of 16.4 seconds. Go ahead, plug that back into your position function and get the 267.1 meters.